Hi, my name is Satoshi. I think this was very interesting. By the way, I saw your homepage before coming here and noticed that you have been fascinated by this area since you were age of 15, which I think is great. So, I have one question. So, the first two of your three pillars was like, first one is coming up with the pointed architecture right and in place, and then coming up with the right neural network within the architecture. What are the most challenging part? Coming up with the pointed theory or architecture itself, I think is challenging and may not be perfect yet. And also implementing this in the actual computer, the programs itself, I believe, is challenging. But if you can explain a little more, what are the most challenging in actually coming up with those software running in the real world?
Yeah, I think this second pillar, which is the correct neural network modules, in our opinion, this is the most challenging. And I think, yeah, cognitive architecture is also important, but I think we have more or less the high-level idea what it should be doing. But having this second pillar where the AI is modeling the world, learning actively without forgetting previous information, using attention for basically just like I said, like modeling the real world. I think this is the most challenging thing. So and that's where the biggest part of our team is focusing their effort. And there can be probably hundreds of different approaches how to do this. And yeah, you can do this with deep learning and all these things, but then if we are talking about the mainstream deep learning, then you will hit some constraint or some obstacle at some point. So for example, deep learning can or the most of the deep learning methods will have problems with this adaptive learning, which means that you can learn it some things, but if you will start learning it completely different things, you will kind of override the existing knowledge. And this is something that doesn't happen with people. I mean, yeah, we can forget stuff, but only if it's not useful stuff or very important stuff. But if something is really important for you, you'll probably never forget. Like you will never forget how to walk, or how to eat, something like this. But you can forget many other things. So to implement all these things in computer, I think that's the most important. And this one, this smooth for artificial intelligence, guided virtual learning, I think it's also kind of challenging, but I think it's less challenging and it's more about just defining it, specializing it, and putting it to computer.
So you said that implementing the neural network modules is more challenging than the cognitive architecture. But if I ask more, this implementation is more challenging because the first part, like architecture, is yet to be defined more precisely.
I think that we defined the architecture pretty good enough, both in our team.
Yeah.
And so let's say we have good specification for the first one, and we have almost good specification for the second one, and now we are working on implementing it. And I'm actually very happy that we are at this stage of thinking that we know that, okay, there is we can write a specification for something, so it's not completely mysterious to us, completely unknown. The worst thing is when you want to develop something and you don't even know what you want, or what are the steps, what is the roadmap. And I think right now we have some understanding. It's very possible that we are just missing something and there will be some bigger obstacle we don't see right now, of course we did. But at least we know what requirements does the second one require, what is the specification, and how to stress test this thing? You know, what are the cases where we will demonstrate that it's doing this? So, for example, we will have through this gradual learning, we will have cases where if you learn how to abstract information, how to, for example, if you learn that this is a bottle, and then we'll show it some other object, and at the beginning it will select also this is a bottle, you know, because there are some common features, for example, the shape or something like this. But if we tell it like, no, this is not bottle, this is a pen, maybe 2 or 3 times it will make the mistake again, but then it will need to understand what's the specific feature by what these two things differ, you know. And so now we know that we want this requirement, we have it in the specification, and we just need to implement these things in this. Right now it's LTM, long-term memory model, but very soon we will stop thinking about this as a memory, and we will keep thinking about this as a representation, some kind of simulation of the real world. So in this model, in this representation, there will actually be some interactions between the entities. It's just like when you see the real world, you represent it somehow, or somehow you represent it in your brain with all the causalities, you know, that are in the objects around you, with all these abstract links and generalizations, and with this attention that you are modeling some part of the world much more deeply. So, for example, right now, when I'm standing here talking with you, I have a representation of the entire world, but very limited, because I don't need to be thinking about our office in Prague, you know, about different people and stuff like that, because my brain wouldn't be able to process all those things at one moment. So in my mind right now, the only active representation is this room, you, and the stuff I'm talking about, and all the other things are not here. But if I will decide that I want to be thinking about something back in Prague, because I want to remember something, or like to tell you some story or something like this, then I will kind of like move there, you know, activate that part of the representation, so my reasoning part of my brain can work on that, and then I can get back here and finish the conversation or something like this. And I would like to give you the specification of this second pillar, but it's not yet finished, and I think we will finish it when we get back from Asia, and then we'll probably actually post it on our blog, so people can see. Was this enough?
Yes.
Okay, other question, please. Go ahead.
So thank you for the information that GoodAI. So I'd like to ask you the more business aspect questions. So as the artificial intelligence develops gradually, so how do you think that how the people feel happy to live with the artificial intelligence objects, like something like the robots, or something like games, or how do you think about, in your opinion, what kind of things people in the markets feel happy and to pay more money to some kind of entertainment? What do you think about it?
So we think that adding AGI to existing products and basically making existing products more intelligent is one of the things where we can start. It's just an example, like these self-driving cars that we have today. It's just like you take a normal car, you know, that is you and you add intelligence to this, which adds a lot of benefits for people, you know, so you don't need to drive everywhere, you can just press a button and the car will go. It's good because people, like there's already a market, there's already an existing industry, and you just need to upgrade this little bit with intelligence. So this is one thing, but funny thing with intelligence is that when I think about this, we can be just adding it to everything. And this is like almost like an evidence intelligence. But right now we don't have much intelligence because the only entities who can do something intelligent really intelligent, like adaptive and so on, are people. Yes, you can have dogs who are also a little bit intelligent. You can program some pseudo-intelligent things in games or everywhere, like houses and stuff like that, but it's really, really intelligent. So, like we can be adding intelligence to everything, and there can be, of course, there can be some constraints. So for example, right now, if the AGI will require really expensive hardware, and you cannot just keep adding it everywhere. Even if you will need, even for this architecture that we have here, if you would need hundreds and hundreds of GPUs to run some good representation environment and drive your car in the environment, you can have hundreds of GPUs in your car, and even if it would work through some cloud or something, you would not pay for it. It would be just too expensive. So there will be probably some low-hanging fruits to this business commercialization. Some really some business applications where adding intelligence will lead to fast results, and we will solve this. And then as time will go, we will also try to get the fruits that are upper on the tree and harder to reach. And at the end, actually, I think that in next decades, the world will change in a way that this is more crazy, but I don't even think we will be living in real world, because they will be just too complex and too energy demanding, and too inefficient. One of my ideas is that we can use intelligence to actually optimize the universe, like things that are around us, to optimize them, to put them together, to arrange them together in a way that's more efficient in using energy and resources and our time and everything like this. And so, for example, to come here to Japan, when I'm thinking about like the cost, not just money, but like energy and time, it's really very expensive thing. You need to fly, there's jet lag and all these things. But if you can do this virtually, in a way that you don't even feel it's virtual, or it would be natural thing, people would start doing this, because traveling to a different continent is just like this, basically downloading a picture from the internet. So this is where I think it will go, and I think it will lead to something like this technological singularity. But again, in a short term, yeah. And one of the things I didn't talk about is narrow AI versus general AI, and this is where our approach is completely different. That we are completely avoiding any narrow AI thinking. That we don't want to commercialize this thing until we are in a situation where we are sure that this is a general approach, not just narrow approach for some specific field. And but again, then if you want to commercialize this in games and not in cars, then it still will be some kind of narrow AI, but at least it will have a promise of a general AI. It will still be a general AI used in some one field like games, but with general approaches. So was this good answer, or should I?
Any other question?
You said that the researcher do the exploitation and the implementation exploit it. And how many different fields the scientists do the research, and how to integrate it for implementations? Now, I think it's very wide field for general AI. So, can you specify what field of research do?
You mean like if we have some psychologists, neuroscientists?
Yeah.
Okay, we have one neuroscientist / psychologist, and other guys are mathematicians and programmers, mostly programmers. And but the thing is that many of them also study a lot about cognitive architecture. So I wouldn't say they are just programmers who don't understand the big picture. It's more like they try to understand the big picture by getting inspiration from biology and neuroscience and all these other fields, but not going too much in detail, because our goal is not to emulate a human brain. Our goal is not to create humans. Our goal is to automate intelligence, and create artificial intelligence that can have some different implementation than human brains, and also maybe different behavior or different result. But to solve intelligence, it should be much more efficient than how humans do this. So we get inspiration from behavioral psychology and neuroscience and all these fields, but it's more like an inspiration, not a specific roadmap that we need to follow, that we need to emulate. So, was this?
Yeah.
That,
So the second is, you said that brain simulator integration with space engines. Do you create some user's intention recognitions, user intention inference engine or something like that?
Yes, but it will be part of the AI. That the AI needs to understand what the player is rewarding it for,
Yeah.
and
So how to integrate to the brain simulator? Which part is for the intention inference or something?
it will be part of the world representation. In this case, it's this long-term memory, or you get input to the brain, then you do some perception, you get some abstract things from this. You put part of this to long-term memory, so you will start to make, put relations between different concepts. Like, for example, this block is there and it's 2 meters from some other block and 2 meters from some other block, and this will help you to make a spatial map of the environment, and then you will make another concept or relation which will tell you that if I am between these 2 blocks and I got something from and I got a reward, if I'm between these 2 blocks and I did this and that, I got reward. And then there is this, right now it's this reasoning module that is reading through long-term memory and doing this reasoning, like induction, deduction, and so on. But yeah, and it's running there and looking for what it should do to achieve some goals. And so right now it's basically like long-term memory and the reasoning are 2 separate parts, like memory in computer and CPU, RAM and CPU. But we will kind of merge it together, or at least that's what I think right now. And then this goal seeking or goal selection part of the brain will be looking to the representation and finding for ways how to get some rewards.
So it doesn't do, you didn't do some abstractions of the series of planning or something like that. If you go to there, there's some abstractions from the
the abstraction.
The abstraction is designed firstly, or you can like
The brain will find the abstract features.
Find some
In this case, it's this long-term memory. The long-term memory will find the abstract concepts from some other
time series,
or it can be some objects or relations between objects and so on. When I'm thinking about this and I simplify this, it's just like this model or this long-term memory is seeing the environment, finding some patterns, and then there's some other part, finding patterns in these patterns, finding patterns in these patterns, and so on. Sometimes connecting patterns on different levels of abstractions. Like sometimes you want to look on really high level thing, but also for low level thing, and like reason about them at the same time, and find causalities in events and so on. And so this is the part that is and should be that we are trying to make it really universal. So what I want to say is that we don't want to program manually any knowledge. The agent needs to make his own representation of the environment by himself. And even this action selection is kind of programmed in it right now. Even the existence of this module that it's looking through the memory and finding for some concepts and relations, it's kind of programmed. But in the future, we also think that even this can be abstracted a little bit, and there can be some part of the representation can learn from these low-level programmed parts of the brain that it needs to be doing reasoning and action selection and so on, and then this much more universal part will take over and continue in executing this thing. This is actually one of the concepts that I didn't mention that we have. It's basically using reflexes as a mentor and basic primitive reflexes. Like, for example, you feel a pain and you will do, you know, this with your hand or stuff like that. And so it's again a guiding principle that's helping you in the beginning when you still are not smart enough in doing smart decisions. So you have some reflex that's helping at least to do some reflexes, to do some simple reflex decisions. And this more universal, more intelligence part of the brain are learning from this. And at center point when the brain knows that his higher level decision will lead to better outcomes, then he will take over and continue with this.
So, is there any hierarchical reinforcement learning?
Yeah, of course, reinforcement learning is a big part of this.
Hierarchical.
Yeah.
It's nice. Thank you.
I have a question that this presentation. You're implementing some kind of task. So, but sometimes this kind of development is go to the narrow or specified task artificial intelligence. So, what's the key point not to fall down to the specified AI, but the general AI? So, what's the key? Yeah, you think?
You mean like, I just want to understand the question. You mean like how are we avoiding narrow approaches?
Yeah, so sometimes your direction is of course general AI, but in the implementation stage tend to go to the narrow AI. Yeah, so we you and of course we have to some strategy not to go to the narrow AI is very important for this kind of
Yeah, it is. And we are basically when we are setting up these training and testing scenarios for guided gradual learning, we are also thinking about not teaching it just some narrow part. So, for example, one of the milestones that I didn't mention was an AI that's able to play multiple games. And right now, this agent that's able to play Pong, he learns how to play Pong, and that's it. Like, if you want to teach him how to play another game,
so you mean the various tasks is from architecture is important for the generalization ability of this architecture?
Yes. So, for example, this multiple game AI will be able to play one game and then we'll present it with a different game. He will learn to play this game and maybe even use knowledge that he learned in the first game to play the second game. So, for example, if you play how to play Pong in the first game and the second game is some variation of Pong, you will not need to learn from beginning. You will just find differences.
And knowledge transfer.
Yeah, knowledge transfer. And for this, we have, or we are planning to have these stress tests. And with these stress tests, we will be testing if the AI is not really just narrow AI, you know, and not just specializing on some narrow problem. And of course, also if it is not overfitting for the narrow problem.
Okay, I'm interested in the training or evaluation environment and for artificial general intelligence. And so you are now using a space engineer for the such kind of environment. And so there is, as you said, there is many other games such like Pong or Super Mario, or Angry Bird as test bed for the artificial intelligence. And so I'm not quite sure about your games. And so Could you tell us some specific characteristics which is necessary for your game in the as an intelligence for the
So you mean like what do we need to? Why do we need to be intelligent to play our game?
Yeah. Maybe yes.
Okay, so it's a 3D environment where you need to understand the environment and the spatial space information in that environment. The environment is dynamic, so things can change. Somebody can build a wall somewhere, close a path for that you have been using, and player can give you reward for this or that, and then it's just up to us what kind of demo examples we will create. For example, we have also another game that I didn't mention. It's called Medieval Engineers, and in Medieval Engineers you have some peasants, like slaves or something, and you can reward them for cutting trees or building some house or stuff like that. And if you will do reinforcement learning on this, then you can reinforce this behavior. And there is also important thing to say that we don't think space or medieval engineers are the best school for these artificial intelligences. Like you really can teach AI in many different virtual environments. It doesn't need to be just our game. The thing is that we do this also for some kind of PR and business reasons. Because, and I didn't say this, the thing is that if we will be successful with having some adaptive AI in our game, and if you will test it and you will see that it's kind of fun to train your AIs and let them, maybe fight together or cooperate together, and so on. So we will, like a teacher, we will not interact directly in the game. Then we can launch this as a new game, and make just money from the new game. And it will be again something really unique because there are some games that try to have adaptive AI, but it wasn't really adaptive AI. Usually they use some little tricks to do this or that, and most of the time it's not really adaptive, which is not like a bad thing. It's like really hard problem. So it's normal that nobody has solved this yet. But if we had a game, think about this again that if we will use our engine and our technology because it's already existing, we don't need to reinvent this, we just reuse. So imagine a game where you are teaching AI characters in some virtual, let's say, arenas, and then you use these trained characters with their brains, put them to a bigger hall where they can interact with other players and achieve some goals or fight or cooperate or just do some funny things. And you can still train the AI, but you cannot interact with the world yourself. So you are just like a teacher who teaches your AI and then lets the AI live its world, and you will be like a happy parent seeing what the AI is doing, but you will not be able to interact with the world again. And so that's the reason why we are trying this in space engineering, because it can be fun and it can make some money.
Last one question.
You have an intention to develop the Mars in space.
To develop
Mars.
Mars?
Yeah.
Like the planet?
Yeah.
In space engineering?
Yeah. No. In real space. It's just like some kind of joke that we need to develop some kind of newly intelligent to develop outer space, outer planets, and if I think we can send some people to Mars in the real Mars, but to develop in the environment of Mars, we need more kind of intelligence like human. So if I suppose you have lots of some kind of knowledges in the artificial intelligence, and I think it's very helpful to develop in the outer space and some kind of like a human in outer space in Mars to develop the Mars for changes environments into the more like the space where is a human live.
So, you mean like creating robots that can fly, that are intelligent, just like human, to fly to Mars, and use some terraformation, to change the Mars, so it's like Earth?
Yeah, so it's like just a business like a SpaceX.
Well, I would say that it's one of the applications of AGI, and we are thinking, like, I think everyone who is working or thinking about AGI wants to end up with something like this, not just stay on this planet, but continue and spread, everywhere. So, and actually I think that using AGI to explore the space is much more efficient than to send real people. Because if you want to send a real human to Mars, like right now, if you do this, it will cost billions of dollars, and he will probably never get back. You know what I mean? It's really complex, and it will be super expensive, like extremely expensive. But maybe let's wait 10 years or 20 years, build some AI, some robot, there's a good body, there is some 3D printer so he can fix himself and all these things. You can send him there. You don't even care if he gets back, because it's just a robot. And he doesn't need to get back because he can communicate with you and live there forever. And he can do his things. You can send him there for a much smaller cost. And you can send him there and he can rebuild himself, clone himself billion times. People can clone themselves billion times. So it was like this traveling to Japan thing, that it's just much more efficient use of energy and time. This is what I think. So, and this is why we want to build AGI as soon as possible, because it will help us to do all these things. Because right now, if you want to send, you can send robots to Mars, and NASA is doing already this. But these robots are not really that much adaptive, they are limited and so on. And also the communications, like it takes a lot of time, and they are not fully autonomous, if I know correctly. And so if you solve this last problem that we have here, automation of intelligence, then I think it will offer like big thing, big revolution.
じゃあ、時間になりましたので終わりにしたいと思います。じゃあ、最後に拍手で。じゃあ、お疲れ様でした。これで終わりにしたいと思います。Thank you for